Hello everyone, and welcome to week 2 of your pharmacy procedures course. This week we're going to still be calculating doses, but we're going to be doing it using another method called dimensional analysis. So last week you used ratios and proportions. This week we're going to look at dimensional analysis, and next week we're going to look at using formulas. So it's kind of a progression. There is no one right way to do these kinds of problems, and it's really just a matter of determining what you're most comfortable with. And honestly, I will tell you that most students struggle a little bit with this particular topic, so doing the dimensional analysis is a little more difficult than the regular ratio and proportion method or the formula method. This particular method is all about units. So it uses units of measure, and it's basically a way to convert from one unit of measure to another, and you can do several at a time. And so that's why some people find it to be a little bit easier. It's kind of like ratio and proportions simplified, because you're doing all of them at once rather than doing several different ratios and proportions. So you can do all of it at one time. Excuse me. However, some people find it to be a little bit confusing. So again, it's whatever method works best for you. Once you find a method that you really understand and you own it, use that method. You don't have to use any one particular method every single time. So it's totally up to you. Use whatever method works best. Now, I've left this entire slide deck for you in the course so that you can look it over. And it matches up with the textbook and how dimensional analysis is explained in the textbook. But I wanted to show you another way. So I've added an additional slide to the slide deck from the manufacturer of the textbook to show you the way I explain it. I believe the way I explain dimensional analysis makes it a little bit easier to understand. If it works for you, great. Again, if it doesn't, feel free to use the books method. But I just think my way, it just kind of makes a little more sense to me. So I'm going to skip to that slide. This is my way. I'm calling it another way. And what I'm doing here is first of all, I'm giving you the question. The question on this one is, how many grams of dexamethasone are contained in this stock bottle? And I've got a picture of the label for you. So the picture's down here in the corner. This is the label of this oral solution. It's dexamethasone. The strength of the medicine is 0.5 milligrams per 5 mils, and this particular bottle contains 500 milliliters. So that's where the question comes from. So we want to know how many grams of the drug are contained in the 500 milliliters. So when I do these kinds of problems using dimensional analysis, I start by identifying the question. So I wrote that question out for us. 500 milliliters is how many grams? And then I take that first part of the question and I write it over 1. And the only reason I do that is just to make it easy when we get ready to do our final multiplication. Now the idea here is to get rid of the milliliters and get to the units of measure we desire. And in this case, the unit of measure we're looking for is grams. So I want to get to the place where I only have grams and I no longer have milliliters. And I do that by multiplying that fraction, 500 milliliters over 1, times pieces of information I know. So I'm going to start with, what information do I know from the problem, or in this case from the label. In this case, I know that there is 0.5 milligrams per 5 mils. And I wrote that as my second fraction. Right here you can see that's my second fraction. And I put the 5 mils on bottom because I want to be able to cancel milliliters. The whole idea is to get rid of the units we don't want so that we end up with the units we do want. So right now, if I stopped where I'm at, the milliliters would cancel and I'd be left with milligrams. But since that's not what the problem is asking us for, we need to keep going. So since the problem says, no, we don't want milligrams, we want grams, I have to take this a step further and convert milligrams to grams. And I do that using this conversion factor. That conversion factor is not in the problem. It actually comes from our textbook. So in our textbook, we learned that 1 gram is equal to 1,000 milligrams. And notice I put the milligrams on bottom because I want to cancel the units. Once I've set my problem up and I've gotten to a point where I can tell that my units are going to cancel and I'm going to be left with a unit that I'm desire, the grams, then I'm ready to do the math. So I rewrote the problem in the last step there, and what we're going to do is we're going to multiply all of the numerators across. We're going to multiply all of the denominators across, and then we're going to just do our division. So 500 times 0.5 times 1 goes on top, and on the bottom we have 1 times 5 times 1,000. When I do that, you will, oh, I caught myself. I see I made a mistake. Let me correct that. That should be a 1, which means this is going to be a 5,000. So now you can see we have 250 over 5,000. And when we divide that, you're going to get that that is 0.0, and that's actually 5.05 grams. So now we have converted milliliters to grams based on this stock bottle, and we were able to do that using dimensional analysis. Again, my dimensional analysis approach is a little bit different than this textbook shows you, but if this is makes a little more sense to you, feel free to use this method as well. If you have any questions over the next week or so, let me know. My number is 618-792-2293. Have a great day.